Let's chat. So we've got this geometric sequence. How do we know it's geometric without it basically saying, hey, it's geometric? Asking for the ratio. How do we find the ratio? The second term divided by the first term. So what did that give us? 3. So the ratio is 3. Remember, there's a difference between geometric and arithmetic. The difference is arithmetic is adding, geometric is multiplying. Geometric, multiplying. Yep. Okay, so for geometric, we're going to write the recursive formula. Okay, it's over there on the board as well as over here. So when we do the recursive, we're going to say a sub 1 is equal to, what's our first term? 0.3. Then we're going to say a sub n is equal to a sub n minus 1 times what was our rate. So the only things that you plug in for recursive is your initial and your rate. Everything else remains the same. Okay. For the explicit formula, we're going to plug in our initial and our rate. So looking at the explicit, we got a sub n equals a sub 1, which is 0.3 times 3 raised to the n minus 1. All you do is substitute in what your a sub 1 is and your r is. So in the formula for your recursive, this is our formula for recursive. We say a sub 1 equals, and then a sub n equals a sub n minus 1 times r. A sub 1 is your first term. A sub n is just representing whatever term we want to look for. A sub n minus 1 represents the previous term, and you're going to take the previous term and multiply it times your rate. So for instance, a sub 1 on this one is 0.3. If we were finding the third term, we would take the second term, which is 0.9, and multiply it times 3. That would give us our third term. That's how you use the recursive formula. Okay. All right, go ahead and try this next one. Again, on a rando sheet of paper or on some blank space. I want you to answer these questions. Notice how they're different. They're not the same questions, or they're not in the same box. So we've got this sequence. Is this geometric or is this arithmetic? Why? Because the ratio is 5, right? We're multiplying by 5. How do we find the ratio? We take the second divided by the first. The recursive formula. Here's the recursive. All we're going to do is we're going to plug in. Okay, so what was our first term? -2. So we're going to write -2 in for a sub 1. For r, it was 5. This is all you're writing for the recursive. So look at what I plugged in. What's the question, Josh?
So you're only doing the first time and what you just.
Hold on. Josh, what'd you say? Is it what we started with? Yes. It's your first term right here, and then your rate is right here. Rami, what? Same thing. Okay, yes. So first term and your rate. Okay. Explicit formula. Here's the explicit formula. I'm writing this from the board. All I'm going to do is I'm going to substitute in what a sub 1 is. What was a sub 1? -2. And then what was your rate? That's it. The rest is the same. So how do we find the seventh term? We're going to take the explicit and we're going to plug in 7 for in. Now, when I say the words plug in, what I mean is you're going to rewrite the formula with 7 in there for in. So watch. A sub 7 is equal to -2 times 5 raised to the 7 minus 1. In your calculator, you are going to type in just this side. Do not ask me how to type in a sub 7. Just type in -2 times 5 raised to the 7 minus 1. Take a moment, type it in. Everybody type it in before we say the answer. Hey, when you typed it in, what'd you get? I got -31,250. Is that what you got?
Yeah.
Okay. All right, try this next one. Now, this is a word problem. Okay. So let's read this together. We got on Bunny Island, there were 3 bunnies after the first month. However, these bunnies are rapidly multiplying. By the third month, after the second month, there were 15 bunnies. By the third month, there were 75. This pattern continues. So how many did we start with? How many do we get the next month? Next month? Okay. When I ask you to write a geometric sequence, this is what I'm asking for. If I say write the first 4 terms, this is the first 3, and then you would write the 4th one. Okay. All right, take a moment, write the recursive and the explicit. This is what I got. This is what you got. Yes. No.
The MI's doing, can you get that like partial credit?
What you mean?
Oh, yeah.
So if we do it right,
Now, arithmetic sequences. We talked about this back in January. You haven't seen it in a little while, but you're kind of expected to know it. So, for instance, if I have something that looks like this, is this arithmetic or geometric? Why? So we're adding 2 each time, right? Ooh, not an X, a plus. Okay. Now, can you write the explicit and the recursive for this? Look at the board.
yes.
Yeah, you can. So explicit, the formula looks like this. A sub n equals a sub 1 plus d times n minus 1. What are we going to plug in? What can we plug in?
5 rather 3.
Okay, so what is our initial? 3. And then what is our common difference? What are we going up by? 2. And then leave everything else the same. Okay. Recursive. Recursive. We're going to write down the formula. We're going to say a sub 1 equals a sub n equals a sub n minus 1 plus d. What is a sub 1? 3. What's your difference? What are you adding? That's it. Yes? No, it's the same amount of steps. The difference between the two is that arithmetic is adding. Geometric is multiplying. Let's have this conversation really quick. If we had a geometric and it looked like this, what's happening here? Don't say dividing by 2. Say something else. Geometric, what do? We multiply, right? Okay, so what are we multiplying by? We're not multiplying by 2. It's going down. By what? 0.5, which is 1/2. How do we figure that out if we don't remember? Well, we take our second and divide it by our first. Don't you dare put multiplying by 2. No, it is multiplying by 1/2 or 0.5. Don't put divided. We will have words. Okay? Good so far. Let's say that I gave you this recursive problem. I said a sub 1 equals 5 and a sub n equals 3 a sub n minus 1. And I said find the first 4 terms. Find the first 4.
First one is 5.
The first one is 5. Good. Now, how do we figure out the second one? It's not 3.
No, that's the rate.
That's the rate. So what do we do with the rate? Multiply. What's 5 times 3? And then 15 times 3? And then 45 times 3? Use your calculator. 45 times 3? What is it? That's how you find the first four terms. So we're given the recursive, we find the first four terms. Questions?
So you only need.
One more like that? Huh?
You only need. You don't like, essentially, you only need the rate in the first.
Number. Yep, and then you can figure anything else out from there. Take a second, find the first four numbers on that one. Should have been 2, I'm dead. 8, 32. Oh, not 16. Sorry, I made a mistake. 32, and then 32 times 4 would be what? 128. Remember, we're multiplying by 4. Yeah. So our initial is 2. Then we multiply by 4. Then we multiply by 4 again. Then we multiply by 4 again. 2 times 4 is 8. 8 times 4 is 32. 32 times 4 is 128.
That's correct.
All right, so number 4 should have been 2, 8, 32, and 128. To find the rate for this one, I want to go over this part, so hang with me. 16 divided by negative 32 gives me what? Negative 0.5. So when you write the recursive, you're going to state your first, and then your rest of your formula. Remember, we're going to plug in that negative 0.5. Don't you dare put divide 2. Don't do it on your mastery check. Okay? Then, so with this box, a lot of people did this. They were like, okay, this is going to be 5 times 5 times 5. Yes. 3 5s, correct. A lot of y'all put 2 to the 5th here. There's 5 2s, which is right. But this is what I saw as some of our answers. What they do here. Multiplied like 5 times 2. Yeah. Okay. Let me tell you what the most frequently used answer down here it was. Ready? Because you probably have it on your paper. Most of y'all put this. Most of y'all put this. Somebody type 9 to the 3rd power in their calculator. Tell me what you get. 720. That's not 27. It's not 27. So we're not multiplying here those two numbers. What we're doing here is we're raising a number to the 3rd power, which means multiply itself 3 times, and that gets us 27. When we multiply 5 times 5 times 5, that gives us 125. And then when we multiply 2 times 2 times 2 times 2, that gives us 32. Okay, so let's go ahead and talk about this. So this is solving simple one variable exponentials. Okay, the TikTok. Do y'all think that TikTok's gonna get banned?
No.
Why not? And it didn't. Okay. All right. So TikTok uses this equation as the algorithm to approximately track the number of followers a famous influencer has each week. Explain the meaning of the numbers 403. Okay, so on your paper, if you have a blank sheet of paper, what I would like for you to write down is the word TikTok. You're gonna write a TikTok example. And then you're gonna write this equation down. You're gonna put follower stands for F and week stands for W. Okay, so thinking this through, what does that 400 stand for? Okay, so that's our initial follower amounts. Okay, so if I had a blank sheet of paper, I would write 400 and it's the initial follower amount. Okay, what about 3? What does 3 stand for? The what? Weeks? What does this 3 represent? We got a W up here. That represents our weeks. What does 3 represent? Rates. What does the word rate actually mean? What we're multiplying by. Also known as ratio, right? Okay, so again, if I had a blank sheet of paper, I would say 3, rate, multiplying by. So the next question says, how long will it take for the influencer to reach 32,400 followers? So if I'm writing this on my paper, I'm going to ask how long to reach 32,000. 400. So I'm writing this on my paper. I would say, how long to reach 32,400? Okay. Now what I'm going to do is I'm going to take my equation and set it equal to 32,400. So I'm going to set it equal to this. Everybody have that down on their paper. Now we're going to solve for W. So the first thing we're going to do is we're going to divide by 400. The reason why we're dividing by 400 is we want that W by itself, but it's attached to all this other junk. So this is going to give us 3 to the W is equal to, somebody type this in their calculator, 32,400 divided by 400. 81. Okay, now we're going to ask ourselves, 3 to what power would give us 81? So if I sit there and I type in my calculator, 3 to the second power, that would give us 9. 3 to the third would give us 27. Try 3 to the fourth. Okay, so W equals 4. What did we do here? Well, we took this and we set it equal to the number of followers. And then we solved. Okay, so when we do that on number 3, is we did 16,000 is equal to 500 times 2 raised to the W. Okay. What do we do first? Well, we divide by 500. What does that give us? 32. Okay. Then we ask ourselves, 2 to what power gives us 32? 2 to the fifth power. So W equals 5. Okay. Now, when it says prove your answer, all we're going to do is we're going to take 500 times 2 raised to the fifth, plug that into our calculator. Guess what that gives us? 16,000, which is what we wanted to find. Go ahead. Why I did all of this wrong? You could estimate. But like, let's say that it was like a decimal, or let's say that this number was like a fraction, a little harder to do, right? 3 to what power gives us 27? So, okay. To the third power. Okay, so x equals 3. All right, on number 7, what's the first thing you're going to do on this guy? Divide by dose. That's why do we divide it by 2? Well, if we divided it by 4, what is the 4 attached to? So we can't divide by that guy. Yeah, because we're trying to get him by himself. So 512 divided by 2 is 256. And then 4 raised to what power gives us 256? 4. So T equals 4. Good. On the next one, this one is the one that trips people up, right? Look at number 6. Pay attention, because you're going to see this on the SAT and you're going to be like, oh, Miss Evans said this. We've got 1/2 raised to the T equals 1/4. Let's say that this was actually 2 to the T power equals 4. What would you tell me the answer is? 2, right? But since these are fractions and they're flipped, like these numbers are on the bottom, we're going to say T equals -2. So that negative exponent flipped the fraction. Can you try number 8? Dividing by 3. And so that's going to give me 2 to the x equals 32. 2 to what power gives us 32? 5. Ta-da! Questions? Okay,